Everyone, we are looking at text and tests, page 42, exercise 1.1. This is simultaneous equations. We're going to start off with just this one, question 1, part 2, which will be a revision of your junior cert work. Hopefully nothing new in it. So you're given two linear equations in x and y in two variables, okay? So anytime you're trying to solve for two variables, you need two equations. For three variables, you need three equations, and so on. The trick with these is always to have the same number of one variable. So I want to have, let's say, the same number of y's. I'm going to multiply that first equation through by 2, and I get myself 6x minus 2y equals 2. And underneath it, the original of the second equation is x minus 2y is negative 8. Okay, and you can see here you've got minus 2y and minus 2y. So if we subtract these, that's the same thing. You'll get 0. Okay, they'll disappear. And that's always the goal, is to make one variable disappear. So you get 6x take away x is 5x. Negative 2y take negative 2y, which is plus 2y, is 0, equals 2 take negative 8 is 2 plus 8 is 10. So 5x equals 10. X is 10 divided by 5 is 2. Then you go back to any one of your original equations, and it says 2 minus 2y is minus 8. Okay, instead of x, you've got 2 minus 2y. Moving things around, let's move that to the right and this to the left. You get 2 plus 8 equals 2y, or 10. Sorry, I'm impinging on my lower work here, so just say 10 equals 2y, y equals 5. Okay, and then very often you'll write your answer as x, y is 2, 5, because what you're doing here a lot of the time is finding where two lines cross. But that represents the equation of a line. That's the equation of another line. And the point where the lines cross is 2, 5. So you write them as a coordinate. Question 5 is something you haven't seen before, which is 3 equations in 3 unknowns. So the first thing I'm going to ask you to do is label your 3 equations A, B, and C. Again, the aim is to get rid of one of your variables. Doesn't matter which one. I'm going to pick y because I can see there's one y there, one y there. I think it's probably one of the easier ones to get rid of, but you can pick anyone. Okay, so make a note as you work. I'm trying to eliminate y's. Okay, just to kind of keep you on track. How do I do that? Well, if I pick the equation A and the equation C and put them together, I've got a plus y and a minus y, so I'm going to get a 0y down here. Okay, eliminate y's. If I take this equation B, 3x plus 2y is 3z, and this equation A, but multiply it by 2. So I'll get 4x minus 2y minus 2z equals 12. Okay, again, I'm going to have 2y minus 2y, 0. So the aim here is to eliminate y's, and what I'll get then is 2 equations in just x and z. So let's have a look. What do I get here? I'm adding here because y and negative y makes 0. So 4x and 2x makes 6x plus 0, if you like, minus 2z minus 11z. That's minus 3z equals 3 plus 6, 9. And you can even simplify that by dividing through by 3. You get 2x minus z equals 3. Okay, I'm going to call that equation D. So we've already had A, B, and C. Over here, 3x and 4x makes 7x. 2y and negative 2y is 0. 3z and negative 2z is plus 1z. And 3 and 12, sorry, is 15. Okay, so we get 7x plus z equals 15. Call that E. Well, if we put D and E together, you got a plus z and a minus z. Okay, later on, you might need to multiply one of these by something. You want it just like we had up here. You've got 2 equations and 2 unknowns, and you might need to multiply both equations to get a variable, the same number of variables in both. We don't need to do that here. 2x minus z is 3, and I'll just put above it. I always try and put the positive on the top, but it doesn't really matter. 7x plus 2 equals 15. If I put them together now, I get 9x plus 0 equals 18. So 9x equals 18. x equals 18 divided by 2, divided by 9, which is 2. I found x, excuse me, I found x. Then I want to come back and find z, so I stick x into either d or e, it doesn't matter. 2 times 2 instead of x minus z equals 3. 4 takes z is 3, so z is 1. And then finally, to get y, I come back to any one of my original 3 equations. I know now x is 2 and z is 1. So let's go with that one. A, it says 2x minus y minus z. 2x minus y minus z equals 6. Instead of x, we're putting in a 2. Instead of y, we're putting in a 1. And we get 4 minus y minus 1 equals 6. That gives 3 minus y is 6. Minus y is 3. And you do 6 take away 3. So y equals negative 3. Okay, again, we'll write our answer. I'm sorry, I'm running a little bit out of space here. You write your answer like x, y, z. So still like a coordinate, but this is a coordinate in 3-dimensional space. X, y is minus 3, z is 1. So this represents where these 3 shapes, so these are not lines, these are called planes, which is, if you can think of a piece of paper that goes on infinitely in all directions, that's a plane. So 3 intersecting planes meet at this coordinate in 3-dimensional space is a way you can think about it. But the procedure there is simple enough. Once you've done it once or twice. Okay, I'm going to do one more, which is question 10. Let me go back to the book here. 44,000 people attended a match in Croke Park. The 2 ticket prices on the day were 30 euros and 20 euros. The total receipts for the game came to 1.2 million. How many people paid the higher ticket price? So this is convert a word problem into a simultaneous equations problem. Most of us, all of us did this for the junior cert, but you'll find this exercise, there's a few tricky ones. Just to talk you through this one, you define x as one variable, the number of people who paid for a 30 euro ticket, y, the number of people who paid for a 20 euro ticket, and then you can say, well, x times 30, so 30x plus 20y is all of the money they made. 30 multiplied by the number who paid 30, and 20 multiplied by the number of people who paid 20, and the total amount of money that they made was 1.2 million. So 1, 2, 0, 0, 0, 0, 0. Secondly, then, the number of people who went to the match, you also have, it's 44,000. You're told that in the question. And, well, that's just x plus y, the people who paid 30 or the people who paid 20. Everybody bought a ticket. X plus y equals 44,000. Okay, I'm going to stop there as well and ask you to finish that yourselves now, because that's the hard part is setting up the simultaneous equation in the first place. Okay, so I'm going to ask you now to do question 1, question 5, finish question 10. You might do question 18, look, which is similar enough. I think you should be able to set up 2 simultaneous equations easy enough and then solve. Okay, I'll see you in class tomorrow.